Okay, question 4. We've got a differentiation and finding some normals and tangents. A skill from core 1, but we're just doing this with higher powers now, core 2, with non-integer powers. So we've got this curve, it has an equation, we're going to differentiate it. As with most core 2 questions, if we're going to differentiate it, we're probably going to have to rewrite one of these terms into index form. So 1 over x squared is x to the minus 2 plus 4x. And we're just going to differentiate that. So drop the power in front, decrease the power by 1. Be very careful, there's a common mistake here to get the power wrong. Negative 2 take away 1 is negative 3. Then 4x differentiates to 4. Right, once we've done that, we're going into, we've given a point on the curve, we want an equation to the normal of the curve. Right, in order to find a normal, we need to know an x coordinate, a y coordinate, and the gradient. We've been given an x coordinate and a y coordinate, so we just need to find the gradient. So to do that, we're going to use dy dx. So substitute our x value in, that's negative 2 times negative 1, negative 3, plus 4. Right, you can type that straight into our calculator, or we can work this out. Negative 1 to the negative 3 is going to be negative 1. Negative 1 times negative 2 is positive 2. 2 plus 4 is 6. That's going to be the gradient of the tangent. So the gradient of our normal is going to be the negative reciprocal of that. It's going to be a sixth. And then all we have to do is just write the equation. So we can do this quite quickly using y, take away the y coordinate, it's the gradient, brackets, x, take away the x coordinate. It didn't ask for any specific form, so that's enough for the marks. Then we move on to something where we have to do a bit of thinking. Now we want the equation of a tangent that is parallel to this line. So we don't know what our curve looks like. Right? So we've got our curve, it's going to look like something. And they've told us they want to find where the tangent is parallel to the line y equals negative 12x. That just means it's got the same gradient. So the gradient of y equals negative 12x is negative 12. In order to find the tangent, we need an x coordinate, a y coordinate, and a gradient. We know the gradient, but we don't know the x and the y coordinates. We don't know where this tangent is sitting. What do we know? Well, we've got dy dx, and we've got a numerical gradient. So where this tangent is, those two things must be equal. Negative 2x minus 3 plus 4 is negative 12. And we have to solve this to find out the point where our tangent is. So negative 2x, negative 3 is negative 16. X to negative 3 is negative 16 divided by negative 2 is 8. Now you've got a couple of choices here that you're solving. Your calculator will do all sorts of strange roots, so if you want to, your calculator will do for you the negative third root of 8. So using the button, negative third root of 8, and it will tell us that x equals a half. The other way is to just, you should be able to work this out by changing this. So x to negative 3 is the same as 1 over x cubed. That means x cubed is 1 over 8, and then if you cube root 1 over 8, you also get a half. So we've got x, we've got our x coordinate, we've got our gradient. Now we need our y coordinate. Make sure we use the right equation. Y was 1 over x squared plus 4x. 1 over x squared plus 4x. So in this case, that's 1 over a half squared plus 4 times a half, which tells us y equals 6. And now we've got all the key bits of information we need in order to write the equation of a tangent. So using the same thing again for a straight line, y, take away the y coordinate, is the gradient. Remember, it's a tangent this time, so we're just using the standard gradient we were told right at the start, times x. Take away the x coordinate. No specific form asked for, so that's fine, we don't have to simplify.